Hi, in today's video we're going to take a look at installing Davinci Resolve on FreeBSD. Let's come down here and download the installer for FreeBSD. Just kidding. We've only got installers for macOS, Windows and Linux. So the question is, how do we install Davinci Resolve on FreeBSD then? Let's take a look at Davinci Resolve running on FreeBSD. So I'll run new name -a and you can see we're running on FreeBSD 14. I'll now open Davinci Resolve from my application launcher and you'll see the splash screen come up. Now open the project and you can see we have Big Buck Buddy down here. There we go, can fast forward. There we go, there's Big Buck Bunny. So as you can see, we've got Davinci Resolve set up here. So what I'm going to do is come across here and open the preferences, and you can see we have Cuda and Nvidia enabled as well. The Linux binary compatibility layer, commonly referred to as the Linuxulator, allows users to install and run unmodified Linux binaries on FreeBSD. In combination with debootstrap, this will allow us to install Ubuntu in a chroot on FreeBSD and then install Davinci Resolve. If we come across to the Github repository for this project, we can have a look at how we can get this installed. So this is Davinci Resolve installed on FreeBSD using the Linuxulator. Davinci Resolve installed in a Ubuntu Mantic chroot on FreeBSD. Features: Nvidia and Cuda enabled. Xwayland on Wayland or Xephyr on X11 is used to display the Davinci Resolve window on FreeBSD. The audio is routed from the chroot to the host using a pulseaudio socket for zero latency. And the video directory from the FreeBSD host is mounted inside the home directory in the chroot. Davinci Resolve is opened using a desktop entry on FreeBSD, just like a native application. The system requirements to run FreeBSD are 16 gig of system memory, 32 when using Fusion, and you're going to need a GPU with at least 2 gig of VRAM supporting OpenCL or Cuda 11. Clone the Davinci Resolve Git repository. Clone this repository by running the following command. We're just going to come across here, copy this to the clipboard, switch across to the terminal, and clone the GitHub repository. Tree listing. The tree list of the Davinci Resolve FreeBSD Git repository. This shows you the structure of the repository and all of the files and folders that are inside of it. FreeBSD, Nvidia and Cuda. Make sure Nvidia and Cuda is set up on the FreeBSD host by installing the following packages, which I've already done. And once you've done that, copy this command here, nv-sgl run nvidia-smi, and switch to the terminal. And if you run that, it should output something like this, showing you the Nvidia-smi driver version and that Cuda is enabled. Debootstrap install. Install debootstrap, which will be used to create an Ubuntu chroot on FreeBSD, and we'll do that by copying this command, sudo pkg install debootstrap, switching across to the terminal and running the command. Doas install. Install doas so we can enter the chroot without being prompted for a password. So copy this command to the clipboard, switch across to the terminal, and install doas with sudo pkg install doas. So if we have a look at the instructions here, what it does is says edit the doas.conf file and change username to your username on FreeBSD. And this is the path to the doas.conf file on FreeBSD, which is user local etc doas.conf. And what we have down here is a link to the doas.conf file in the repository. You can click here and you can see the file. And what we have down here is the actual path to the doas file in the repository, which is Davinci Resolve Freebsd user local etc doas.conf. So the structure of the repository mirrors the structure of the FreeBSD file system layout. And then finally what we have down here is doas.conf code, and this is showing us the code that we need to put in our doas.conf file. So what we want to do is edit user local etc doas.conf and add in this snippet of code and change username to your username. What this does is permit your username, and we have a command down here, permit no pass username command chroot, so you need to change username here as well to match your username on FreeBSD. And finally we have a command that allows root to run as root. So what we're going to do is just come across to this file here and have a look at it. And you'll see I already have this set up, and if I scroll down here, what you'll see is the chroot command, permit no pass username command chroot. And what that's going to do is allow us to execute the chroot command without being prompted for our password, and we're going to use this to actually build a desktop entry for Davinci Resolve to be launched on FreeBSD, again without being prompted for a password. Stop Linux if it's running. If you have CentOS installed in /compact Linux, you need to stop it before starting Ubuntu, because you can only run one instance of the Linuxulator at a time. If you don't have Linux installed in compact Linux, you can skip this step. So let's have a look in the terminal here. As you can see, I have both Linux and Ubuntu installed. So let's follow the steps. Stop Linux. Sudo service linux stop. So that will stop Linux. Sudo service linux stop. Next step, use sysrc to set linux_enabled equals no in your etc rc.conf. So copy that to the clipboard, switch across to the terminal. Sudo sysrc linux_enabled equals no. You can also do this by manually editing your etc rc.conf and setting linux_enabled to no manually. If we have a look at this file, you'll see as I scroll down here, Linux enabled equals no. And then finally what we need to do is reboot so that the Linux mount points are unmounted. Ubuntu rc.d script. Here's the link to the Ubuntu script. You can open them in the browser. And here is the path to the Ubuntu script in this repository. What you need to do is copy the Ubuntu script from the repository to user local etc rc.d on FreeBSD. And what we do is run this command here. So we'll switch across to the terminal. And all of these commands are from outside, the path is from outside the repository, as it were. So as you can see here, if I list, there's the repository, and what I'm going to do is run sudo cp Davinci Resolve Freebsd user local etc rc.d Ubuntu to user local etc rc.d on the FreeBSD host. And if we come across down here, the other thing we need to do, just make sure the script is executable. which it should be by default, and you can see down here the link to the Ubuntu code that we're using. Create the Linuxulator mount points for Ubuntu. Create necessary mount points for the Ubuntu Linuxulator chroot in compact Ubuntu by running the following command. What we're going to do is just copy this command across here, switch across to the terminal and paste it in. And what that's going to do is it's going to create a directory structure that will be used by Ubuntu for certain directories. And we can have a look at the directories that it will create. Compact Ubuntu, and you can see here, apart from the Davinci Resolve one, these are some of the directories that will be created by that command. Enable the Ubuntu service. Use sysrc to set ubuntu_enabled equals yes in your etc rc.conf. This can be done using sysrc or by manually editing the file. To use sysrc, we copy this command, switch to the terminal and run it. So that's sudo sysrc ubuntu_enabled equals yes. This can be done manually as well by editing your etc rc.conf and setting Ubuntu enabled to yes. So let's have a look at the etc rc.conf file. And you'll see down here I have Ubuntu enabled equals yes and Linux enabled equals no, which we did in the previous step. Once you've done that, you need to start the Ubuntu service by running sudo service ubuntu start. So that's sudo service ubuntu start, and then check what is mounted, and you should see that these directories are mounted in the Ubuntu chroot. Create the Linuxulator script for Luna and Mantic. Debootstrap has a collection of scripts to install different versions of Debian and Ubuntu. The debootstrap scripts are installed in this location on FreeBSD, which is user local share debootstrap scripts. So let's have a look at that directory. And as you can see here, we have a list of the different versions of Ubuntu and Debian that you can install. So what we need to do is actually read this important note here. Ubuntu-Jami is the latest version of Ubuntu included as a script with debootstrapped. However, there seems to be a bug with Ubuntu-Jami inside a chroot on FreeBSD that sets the permissions of a lot of binaries and libraries in the Ubuntu chroot to 700, which means that only the root user can execute the binaries and libraries, so you would have to run a GUI application as root, which is not something we wanted to do. So I've copied one of the existing debootstrap files and added the Luna and Mantic versions of Ubuntu to the file, which we will use later to install Ubuntu Mantic, which doesn't have the permissions bug. So what we have here are the Luna and Mantic scripts in this repository, and they are basically the same script with a different file name. So this is the path to the Luna script in the repository, and what you need to do is copy the Luna script from the repository to the bootstrap scripts directory by running this command. We'll copy this to the terminal, and again we're outside the repository. We'll run sudo cp Davinci Resolve Freebsd user local share deb bootstrap scripts Luna, the user local share deb bootstrap scripts. So that's the first step. The next step is we need to copy the Mantic script. So this is the path to the Mantic script in this repository. So we need to copy the Mantic script from the repository to the bootstrap scripts directory. We copy that to the clipboard, switch across to the terminal, sudo cp Davinci Resolve FreeBSD user local share deb bootstrap scripts Mantic, the user local share deb bootstrap scripts. Okay, So we've done all of that, and you can see here, this is the link to, this is the Luna and Mantic code. And basically what I've done here is added Luna and Mantic to this existing script and renamed it to Luna and Mantic, and we're going to be using that in the next step. Debootstrap install Ubuntu. Use debootstrap with the Mantic script we created earlier, as well as the URL listed below to the Ubuntu archive with Luna and Mantic, and install Ubuntu into this location on FreeBSD. That's compact Ubuntu. What we need to do is copy this command to the clipboard and switch across to the terminal. And what we're doing here is we're running sudo debootstrap arc AMD64 no check GPG Mantic, so that's going to install the latest version of Ubuntu, and it's going to be installed into compact Ubuntu, and we need this URL at the end, archive.ubuntu.com Ubuntu, because that has the listing of the Luna and Mantic images that we're going to install into the chroot. So that's the step we need to do, and if I come across here and copy the URL, you'll see the URL we're actually using if you give it a second. And what you can see here in dists is here are all the versions of Ubuntu, and you can see Luna and Mantic. Restart Ubuntu. Restart the Ubuntu service to make sure everything is properly mounted. I'm going to come across here and copy this, switch to the terminal, and run sudo service ubuntu restart. Chroot into Ubuntu with doas. Use doas to chroot into Ubuntu as root without a password. We come across here and copy this command, switch across to the terminal, and run doas chroot compact ubuntu bin bash. You'll now see we're logged in as root into the chroot in Ubuntu. Set the correct time zone inside your chroot. You'll now be logged in as root inside the chroot, and we need to run this command to correct the time zone. So copy this to the clipboard, switch across to the terminal, and make sure you are inside the chroot, and then run the following command, which will adjust the time zone. We now need to install sudo. So as we're root, we just run apt install sudo, apt install sudo, and then the next step is we need to reconfigure the time zone, and for some reason sudo is necessary here, otherwise it fails even though we're root. So run dpkg-reconfigure tz data with sudo. So copy that command, sudo dpkg-reconfigure tz data, and in the window that appears, what you need to do is select your time zone. Fix the apt package manager. Run the following command as root. I'm going to copy this to the clipboard, switch across to the terminal, make sure that you are in the chroot and not on the FreeBSD host, and then run the following command to fix a bug with the apt package manager. Enable more repositories. Edit the apt sources.list and add more repositories. Trusted equals yes is needed for Luna and Mantic. This is the FreeBSD path to the sources.list in the chroot, so that's compact ubuntu etc apt sources.list, and this is the path to the sources.list inside the chroot, which is etc apt sources.list. What we have here is a link to the sources.list we're going to use. As you can see, deb, trusted yes, and the various repositories that we want to enable. So what we need to do is copy the sources list from the FreeBSD host to the Ubuntu chroot, and we do that by running the following command. So copy that to the clipboard, and what we need to do is actually do this from the FreeBSD side. So you can see here, this is me logged in as the chroot, so I'm going to open another terminal here. Go. So what I'm going to do is switch to the desktop, and as you can see, we have the Davinci Resolve Freebsd GitHub repository. So what I need to do is run this command. Sudo cp Davinci Resolve -freebsd compact ubuntu etc apt sources.list to compact ubuntu etc apt sources.list. Apt update. Run the following commands as root to update and upgrade Ubuntu. We're going to copy this to the clipboard. That's apt update. Switch across to the terminal and make sure you are in the chroot and not on the FreeBSD host. And then we're going to run apt update. And as you can see, we're already root, so we don't need sudo. So run apt update. And then upgrade. Apt upgrade. Set locale. In this step, we're going to set the locale inside the chroot. And this is the FreeBSD path to the locale file in the chroot, which is compact ubuntu etc default locale. And this is the path to the locale file inside the chroot, which is etc default locale. So basically, the path on FreeBSD just has compact ubuntu prepended to it. Here is the link to the locale file in this repository, and this is the path to the locale file in the repository. And what you need to do is change the locale file to match your locale. So what you need to do is basically edit this file. And it's easier to edit these files from the FreeBSD host as opposed to from inside the chroot. So if I switch across to a terminal here and run less, and then that file path, which is compact ubuntu etc default locale, you'll see I have set the locale. So what you can do on FreeBSD as root, use your favorite editor to edit that file and set your locale. Right, in the next step, what we need to do inside the inside the Ubuntu chroot, we need to run the following commands as root to generate the locale and then reconfigure it. So what we're going to do is copy this command here and switch across to the chroot, and always make sure before you run a command that you are in the chroot and not on the FreeBSD host. So after setting the locale file, we're going to run locale-gen. The next step is to then run dpkg-reconfigure locales. dpkg-reconfigure locales. This will open a window where you can select your locale and enable it, or you can enable all locales. Shell install. Install the shell our user is going to use. It must match the shell in the Ubuntu etc password file, which we will set up later. Run the following commands as root. I'm going to copy this to the clipboard. And you can see I'm installing ZSH and pulseaudio. So apt install ZSH and pulseaudio. If you want to use another shell, that's absolutely fine. But the important thing to note is the shell you're installing at this stage is the one that must match the entry in the etc password file that we will set up in a later step. Copy user and group from FreeBSD to Ubuntu. The Linuxulator will create a nullfs mount point for our home in the chroot that is already set to our username. So if we used user add to create a user with our username, it will give you an error that the home directory already exists. We can just copy the settings from our FreeBSD user file to the password file on Ubuntu and do the same thing with the group file. So this is the path to the password file on FreeBSD, etc. password. Have a look at that. Make sure that you're on the FreeBSD host, and we'll just run less etc. password, and you will see down here, where's my user? Yeah, okay, so here's my user. So this is the entry that we're looking for, the user. We've got the ID, the username, the home directory, and the shell that the user is using on FreeBSD. Okay, so this is the path to the password file on Ubuntu. So this is the path from the FreeBSD host to the etc. password file on Ubuntu, and the path to the file inside the chroot is etc. password. So what we want to do is copy the user entry in the etc. password file on FreeBSD to the etc. password file on Ubuntu. And what we need to do is we also need to make sure that the path to the shell on Ubuntu is set correctly, because the path to the ZSH shell on FreeBSD is different than the path to the shell on Ubuntu, and if it's not set properly, you won't be able to log in as your user. So what we're going to do, if I come across here, I said, let's have a look at that file again. And where were we? If I can find my username again, it was in here a second ago. Ah, there we go. I just saw it flash up somewhere. Yeah, here. So what you need to do is edit your etc. password file and copy this entry. So what we'll do is we'll open up Emacs, etc. password, and we'll just copy that to the scratch buffer so you can see. So what we have here is the username, the group, the full name, the path to the home directory, and the path to the shell. So this is the path to the shell on FreeBSD. So what we need to do is actually add this to the etc. password file inside the chroot. So as I said, what you can do is actually edit the file inside the chroot from the FreeBSD host, because it's a lot easier. So what I'll do is across here, I'm not actually going to edit this. So Ubuntu, compact Ubuntu, etc. password. And if I come down to the bottom, what you'll see here, I enlarge this a bit. Okay, so this is the FreeBSD, etc. password entry. The important thing that you need to change is this section at the end, which is the path to the shell. And this is why we installed the shell in a previous step. Okay, so what you need to do is change the path to the shell on FreeBSD in Ubuntu. So on Ubuntu here, the path to the ZSH shell is bin ZSH, and you can find the path to the shell by running which ZSH or whatever shell you want to add. So the only thing that we have changed, copying across the etc. password entry from FreeBSD to the Ubuntu chroot, is the path to the shell. That's the first step. Okay, I'll just close that file there, switch across. So what you can also do is, if I come across here on FreeBSD, this is the FreeBSD host. If you run ID, it will print out your ID, your group ID, the groups and the groups that your user is in on FreeBSD. So what we're doing is we're basically setting the same group and user IDs inside the chroot that we have on the FreeBSD host, and what this will mean is we won't have any permission issues because the user has got the same user ID and group. So we'll be able to copy things into and out of the chroot's home directory without any issues. So that was the password entry. The next thing is you need to copy the group from FreeBSD to Ubuntu. So this is the FreeBSD etc. group entry, so we can have a look at that. So less etc. group, and what you'll see is where's my user? Okay, so what we're looking for is this section here, your user group entry, so username and the group ID here. So we do the same process that we did previously for the password file. So etc. group, etc. group. So what we're going to do is copy our group there. So this is the group entry for our user on FreeBSD in the etc. group file. We're now going to add that to the etc. group file inside the chroot. And as I said, the easiest way to do this is by editing the file from the FreeBSD host. So just remember, the file path inside the chroot is the same as the path from the host, but without the compact Ubuntu. So the full path to the it just makes it easier to figure out the actual path. So compact Ubuntu etc. group. Okay, and if I come down to the bottom, you will see that I have added the group ID from the etc. group file on FreeBSD to the etc. group file inside the chroot. So the path from the FreeBSD host to the file is compact Ubuntu etc. group, and the path inside the file is etc. group. So hopefully all that section makes sense, and that's just done so that we will have the same group and user IDs inside the chroot as we do on the FreeBSD host. Add user to groups in the chroot. Add the user we created to groups in the chroot. Replace username with the username that you created and run the following commands as root. So what we're doing here is we're adding our user that we just created to various groups inside the chroot. Now you can manually run these commands one by one, or you can edit the compact Ubuntu etc. group file, which inside the chroot and the chroot the path would be etc. group. Sudo setup. Run the following command as root inside the chroot. Edit the sudoers file with vi sudo. Copy that to the clipboard. Make sure you are in the chroot, and as you can see here, we are root. So vi sudo. And what you want to do is come down here, and you can see we have the entry for root, and what we do is we just copy that and add our username here and then save the file. Password. Create a password for your user, replace username with your username, run the following command as root. Copy that to the clipboard, switch across to the terminal. Make sure you are logged in as root into the chroot. Run password username and replace username with the username you created in the chroot. You will then be prompted to create a password which you should remember and write down. Couldn't resolve hostname fix. Add your hostname from FreeBSD to the host file in the Ubuntu chroot to stop errors when using sudo saying couldn't resolve hostname. So this is the FreeBSD path to the host file in the chroot, compact Ubuntu etc. hosts, and this is the path to the host file inside the chroot. And what we need to do is edit that file and add the host name from the FreeBSD host to that file. Hostname, so run hostname on the FreeBSD host, which will show you the hostname there. And what you need to do is edit the compact Ubuntu etc. hosts file, and as you can see here, by default it will have 127.0.0.1 localhost, and what you need to do is add 127.0.0.1 and then the host name from the FreeBSD host, and save the file. Switch to our user with su. We're going to run the following command to chroot into Ubuntu using doas without a password. So I'm just going to come across here and log out and then log back in. So doas chroot compact Ubuntu bin bash. We are now logged in as root, as you can see. So the next step is to run su dash and then username and replace username with the user that you have created in the chroot. Su dash and then your username, and you'll see I am now logged in as my user. Now this is the user that we created in the chroot, and as you can see here, here is the ID, the username and the group, and all the groups we have been added to. And if I switch across to FreeBSD and run ID, you'll see that we have the matching user ID and groups that are inside the chroot. So you can see here the yes master prompt is for FreeBSD, and to make things easier, I've changed the prompt inside the chroot to say Linux. So you can see here again the user ID inside the chroot matches the user ID on the FreeBSD host. Davinci Resolve install. Davinci Resolve install on Ubuntu with Nvidia and Cuda. Nvidia download. Download the Linux version matching the version on the FreeBSD host. The version must match exactly or it won't work. The first thing that we need to do is find out the version of the driver that we're using on the FreeBSD host, and you can do this by running nvidia-smi. And this is going to print out the driver being used, and as you can see here we have 535.146.02. So we need to download the exact same driver version for Linux as we have on the FreeBSD host. And the reason why we need to manually download this is because the version inside, the version in the repositories for Ubuntu doesn't match those on the FreeBSD host, and that's why we need to manually download it. So we come across to this link here, you will see this page, and let me just do that, where you can actually select the driver that you want to use. So you need to come through here, and obviously don't download the Linux version and the Windows version. You need the Linux 64-bit version. So in my example, I'm using the 535.146.02, and this is the download link for that. As you can see, what we have here is version 535.146.02, and it's Linux, and we have a download link here. So we're going to click the download link, agree and download, and that's now going to download, and that will take a couple of minutes to download because it's about 300 meg. So we're going to leave that to download, and then we'll come back to the next step. Copy the Nvidia run file into the chroot home directory. Change into the directory you downloaded the Nvidia drivers into on the FreeBSD host, and then copy the Nvidia run file into the home directory in the chroot. Copy the command, switch across to the terminal, and we're going to run cprv, the path to the run file, compat ubuntu home, and then user, which will match the username on the FreeBSD host. Chroot into Ubuntu. Chroot into Ubuntu by running the following commands: doas chroot compact ubuntu bin bash, and then switch to your user, replacing user with your username. Nvidia pre-install requirements. Verify the system has build tools such as make and GCC installed. Install build essentials for GCC. So sudo apt install build essentials. So make sure you have chrooted into Ubuntu and switch to your user using su- and then the username. Check the ID that you're running under. Double check that you're running this inside the chroot. That's why it may be an advantage to set the prompt to Linux so you don't forget. And then we're going to run sudo apt install build essential, and then enter your password at the prompt. ffmpeg install. Sudo apt install ffmpeg. Copy the command to the clipboard. Switch to the terminal. Make sure you are logged in to the chroot as your user, and then run sudo apt install ffmpeg. Nvidia driver install. Change mod the Nvidia run file. We're going to run changemod +x and then the Nvidia run file. I'm going to copy this to the clipboard, and remember to change the version number if you're running a different version. We're going to switch across to the chroot, and we're logged in as our user here. And you will see the Nvidia run file. So run changemod +x on it, just to make sure that it is executable, and double check the permissions here. The next step is we need to install the Nvidia driver by running this command, and what I'm going to do is just copy this here, and I will switch across to Emacs and paste that in. Let me just get rid of that. So what we have here is this command is run as sudo, and these are the things that we need to set: install compact 32 lib, no Nvidia mod probe, no backup, no kernel module, no nouveau check, no kernel module source, and no systemd. And the no systemd is important because there is no systemd on FreeBSD, and so there is no there is no systemd inside the chroot. And credit to Zio Mario on the FreeBSD forum for this command, and this helped out a lot. So what you need to do is basically switch to the terminal inside the chroot as your user. Oops. And run the following command, making sure to change the version number here if you are using a different version of the Nvidia driver. And remember, this driver must match exactly the version on the FreeBSD host. Close enough is not good enough. If it doesn't match exactly, it won't work. Xoriso and fakeroot install. Install fakeroot and Xoriso for makeresolvedeb. Makeresolvedeb is a script we will be using later to create a deb installer from the Davinci Resolve install, which will make it a lot easier to install on Ubuntu. So copy the following command to the clipboard, switch across to the chroot, make sure you are logged in as your user, and then run the following command. Nvidia Cuda toolkit. Install the Nvidia Cuda toolkit. Now copy the following command to the clipboard, switch across to the chroot, and sudo apt install Nvidia Cuda toolkit oclicd opencl dev, and that's a package that is needed for the Davinci Resolve splash screen that comes up when you load Davinci Resolve. And then we install a couple of other packages, including initramfs tools, which we'll use when we blacklist the nouveau driver. Blacklist the nouveau Nvidia driver. The path to the blacklist nvidia-nouveau.conf in this repository is at this location. Davinci Resolve Freebsd, compact Ubuntu, etc. modprobe.d blacklist nvidia-nouveau.conf. And this is the path from the FreeBSD host to the file in the chroot, and this is the path to the file from within this, the chroot. So what we need to do is copy this command here to create the directory and then copy the file across. So switch to the FreeBSD host here and run sudo mkdir-p compact Ubuntu, etc. modprobe.d. After you've done that step, you need to come across here and copy the code to copy the blacklist nvidia-nouveau.conf from the repository into the chroot. So again, switch to the FreeBSD host and make sure you're just outside the repository, like that. So sudo cp Davinci Resolve compact Ubuntu, etc. modprobe.d blacklist nvidia-nouveau.conf, and we're copying it into compact Ubuntu, etc. modprobe.d, which is the directory we just created. Update initramfs. What we need to do now is, after blacklisting the driver, is update the initramfs. So we're going to copy this command, and what we need to do is make sure that we have change rooted into Ubuntu before we run that command. So doas chroot compact Ubuntu bin bash, switch to our user su dash the username, and then run sudo update dash initramfs dash u. Davinci Resolve download. Go to the Davinci Resolve website and click the Davinci Resolve free download now link. So come across to the site, scroll down, and then click the link for Linux for either the free or the studio version. Once that's downloaded, we're going to copy the zip file into the chroot home directory by running this command. So once it's finished downloading, which may take an hour or so because the file is about 2.4 gig, switch to the terminal and run cp rv davinci resolve.zip compact Ubuntu home user. Makeresolvedeb download. On the FreeBSD host, download the makeresolve script. Come across, download it. Copy the makeresolve tar.gz from the FreeBSD host to the home directory in the chroot. Copy that across. There's the file. cprv makeresolve.tar.gz compact Ubuntu home user. Makeresolve create deb file. Make sure you have chrooted into Ubuntu by running doas chroot compat ubuntu bin bash, and then switch to our user in the chroot by replacing username with your username in the following command, su-username. So let's do that. If you haven't already chrooted into the Ubuntu chroot, come across here, doas chroot compat ubuntu bin bash. We are now logged in as root. We now need to switch to our user running fu dash and then our username. And you'll see we are now in the home directory in the chroot. So the next step is we need to install zip so that we can unzip the Davinci Resolve zip file. So come across here. Make sure that you are in the chroot and not on FreeBSD, and that's why I would advise setting the prompt to something like Linux or Ubuntu or whatever, so that you can easily recognize that you're on the chroot as opposed to the FreeBSD host. Run sudo apt install zip. Okay. Then we need to extract the makeresolve tar.gz file by running this command, tar zxvf makeresolvedeb tar.gz. So copy that. Again, make sure you're in the chroot. List the files to make sure that the file we're working on is listed. Okay, so that's extracted it. You can see here the file has been extracted, the script has been extracted. So after we've done that, the next step is to run makeresolve, the makeresolvedeb script with the Davinci Linux run file. So let me just check that I've got that. So actually, let me just cheat and copy one I've already got here before in Blue Peter fashion. CP documents Davinci Resolve run. That a second or two. Right, okay. So what you need to do is we can remove the tar.gz now. We'll remove the makeresolvedeb.tar.gz. Just remove that to clean things up. So I've installed the Nvidia driver, so I'll just remove that as well. Okay, so what we have here is two things: the makeresolvedeb script and the Davinci Resolve.run file. Make sure they're both executable. And what the makeresolvedeb script does is it creates a deb package for Davinci Resolve that we can then install on Ubuntu, and this makes it easier to uninstall if we need to upgrade Davinci Resolve. So what you need to do is come across and copy this line here, and if the versions numbers are different at the time of you watching this as opposed to me recording it, then change them appropriately. So makeresolvedeb 1.64 Davinci Resolve 1865, and then run that. Now this can take about an hour to actually create the deb file, so you'll need to be patient for it to finish. Davinci Resolve deb install. Once we have created the deb file, we're now going to install it using either dpkg or apt. So what we're going to do is run sudo dpkg-i Davinci Resolve and the name of the deb file. I'll come across here, copy that to the clipboard, switch back into the chroot, and as you can see here, I have the deb file that has been created using the makeresolvedeb script in combination with the Davinci Resolve.run file. And what we're going to do is run sudo dpkg-i and the path to the deb file. libglib fix. Change directory in the chroot to the resolves lib directory by running cd opt resolve libs. We'll copy that to the clipboard. switch across to the chroot and change directory. The next step is to rename libglib-2.0.so.0 to libglib-2.so.0.back. So copy this command to the clipboard. Make sure you're in the opt-resolve libs directory, and then run sudo mv to rename the file with a .back extension. And this is needed to fix a error in Resolve with the libglib library. So once we've done that step, what we're going to do is copy the libglib from the Chroot system lib directory to the resolve libs directory by running this command. Copy that. Sudo cp user lib x64 linux gnu libglib2 to opt resolve libs. Okay. And then the final step is we also need to install lib log 4cxx dev, because otherwise you get an error if this isn't installed. So copy that to the clipboard, switch across to the chroot and install it with sudo apt install lib log 4cxx-dev. GPU set up in the chroot. Make sure you have chrooted into Ubuntu by typing doas chroot compat ubuntu bin bash, and then switch to our user in the chroot, replacing username with your username. Across to the terminal. Su. So we're now logged into the chroot as our user, and then we want to create the GPU directory. So again, this is in the chroot mkdir-p home.config GPU. On the FreeBSD host, copy the dummy uvm.so from the repository to the chroot. So just copy this command here. Make sure you're on the FreeBSD host. You're just outside the Davinci Resolve FreeBSD Git repository. And then run the following command: cp Davinci Resolve FreeBSD compat ubuntu home username.config gpu dummy-uvm.so to compat ubuntu home user.config gpu. Wayland install. Wayland packages. Install some Wayland packages and the wlroot compositor inside the chroot. Come across, copy the command, switch to the terminal, make sure you are in the chroot logged in as your user. And we're going to run sudo apt install libinput tools Wayland protocol libwlroots11 libwlrootsdev libxkb common 0 qt wayland 5 qt6-wayland wayland utils adwaita qt and qt5ct. Now, although Davinci Resolve is actually not a native Wayland application and it runs under Xwayland, what we're going to do is we're setting up a full Ubuntu install inside this chroot to ensure that we have everything needed. Create the xdg runtime directory in the chroot. Copy the first command. Make sure you are logged into the chroot as your user. And we're going to run sudo mkdir-p var run user and then your user ID. Okay, so the second command, we're now going to chown the directory. So copy that across. Switch to terminal. Sudo chown -r user, your ID, var run user, and then your ID. Okay, and then finally, I'm going to change mod the directory. Copy that across. Sudo change mod 700 var run user and then the ID. We need to set some environmental variables in our shell config. So copy the zsh rc config from this repository to the chroot. Make sure you're on the FreeBSD host. outside the Git repository like this. Then run the following command to copy the Davinci Resolve Freebsd compat Ubuntu home username.zshrc to compat Ubuntu home user. That's the first step. Second step, copy the zsh env config from this repository to the chroot. So copy that, switch across to the terminal, run that command, cp Davinci Resolve Freebsd compat Ubuntu home username.zsh env compat Ubuntu home user. Right, so let's have a look at this. So first of all, the zshrc, we create a blank zshrc file, otherwise zsh will complain that there's no config, and you can add your own code to that. And then in the zsh env file, what we're doing is a couple of things. We're setting the shell path to include the resolve bin directory, and this allows us to type resolve instead of the full path to open Davinci Resolve in the chroot, which would be opt resolved bin resolve. We export some XDG directories, having remembered to create the XDG runtime directory we did in the previous step. The LD preload is used to load the SO file. We also need to set some environmental variables for Nvidia, otherwise you won't be able to drag a clip into the timeline and you'll get an error saying that the GPU is full. So these are the two things we're exporting, and then finally down here we're exporting the display. So applications use the Xwayland window on the host, so that's export display 1, and Davinci Resolve is not a native Wayland application, so we need to set QPA platform to XCB. So you can see down here, this is the code. We're exporting the path with opt bin resolve, opt resolve bin rather. We're exporting the XDG directories, the XDG runtime directory. We're exporting the LD preload for the dummy-uvm.so, the Nvidia fixes, exporting the display, and also exporting QPA platform to XCB. X11 install. X11 install on Ubuntu in the chroot. Copy the command to the clipboard. Switch across to the chroot and run sudo apt install xorg x server xorg x server -xorg -core. Nvidia SMI. Use Nvidia SMI to see GPU info and processes that are using the Nvidia GPU. Run the following command as your user in the chroot, and it should output something like this, showing the Nvidia SMI, the driver version, and Cuda. Copy that to the clipboard, switch across to the chroot, Nvidia SMI, and you will see the driver version and Cuda enabled inside the chroot. Default.pa. Use the pulseaudio default.pa config file to create a pulseaudio socket in the temp directory. The temp directory is mounted in the chroot and allows us to route the audio from the chroot to the host. So copy the default.pa from this repository to .config pulse default.pa. Copy the command here. Switch across to the terminal. Make sure outside the Git repository. Then run the following command to copy Davinci Resolve Freebsd home username.config pulse default.pa to home.config pulse. If you don't have that directory, create it already, but if you install pulseaudio and start it up, it will create the directory. So next step is to have a quick look at the code. As you can see here, this is the default.pa code, and what we're doing is we're including the user local etc pulse default.pa file and then overriding it. And what we have here is we're checking if the module eSound protocol unix.so exists. If it does, we're loading it, and then what we're doing is using it to create a socket in temp pulseaudio.socket. Client.conf. Full path to the client.conf from FreeBSD to the chroot. And that would be compat Ubuntu home your username.config pulse client.conf, and the path inside the chroot would be .conf pulse client.conf. So what we need to do is copy the client.conf from this repository into the chroot. Come across here, copy that to the clipboard. Make sure you're on the FreeBSD host. You've got the repository there. And what we're going to do is run cp Davinci Resolve Freebsd compat Ubuntu home username.conf config pulse client.conf compat Ubuntu home user.config pulse. And that's going to copy that file into the pulse directory inside the chroot. And if we have a look at the client.conf code here, what you will see is the default server equals pulse temp pulseaudio.socket, which is the socket we created in the previous step. Davinci Resolve checklist. Starting Davinci Resolve manually on Wayland and X11 running on FreeBSD. We need to manually test the steps to launch Davinci Resolve before setting up the desktop entry for FreeBSD. So on the FreeBSD host, we need to start Pulse Audio with the demonize option. Leave that to the clipboard. Switch across to the terminal, make sure you're on the FreeBSD host and run pulse audio --start --demonize. Make sure the pulse audio socket is created in the temp directory. The pulse audio socket is created by the default.pa pulse audio file you set up earlier. So list the temp directory and you should see the pulse audio socket listed. Create the Xwayland or Xephyr window on FreeBSD. We use Xwayland on Wayland or Xephyr on X11 to create a new window with an ID of 1. In the chroot, we set the display variable to equal 1 so that applications are displayed in the FreeBSD window. On Wayland, we can create a full screen 19x20 window by running the following command: xwayland-host-grab fullscreen-geometry 1920x1080:01. Host grab is needed so you can click around in Resolve and press Ctrl plus Shift to release the mouse. I'm going to copy that to the clipboard and I'm going to come across to the terminal and I'm going to run this command, and what this will do is it will create a black window that is full screen, and you can come out of the full screen mode just like you would any other application and quit it using your usual keys to quit. So when I press this command, it will create a new window that will overlap the entire desktop. X11. Install Xephyr if you are running X11 on FreeBSD by running sudo pkg install Xephyr. You then create a 1920x1080 full screen window by running Xephyr-br-ac-no reset-screen 1920x1080:1 and press Shift and Control to release the mouse. Chroot into Ubuntu. Use doas to chroot into Ubuntu as root without a password if you haven't already. We're going to run doas chroot compat Ubuntu bin bash and then switch to our user with su- and then our username. Printenv. Run printenv in the chroot and check the display variable is set to 1. So run printenv inside the chroot and we're going to check these following things are set. So make sure in the chroot and run printenv, and this is the output. So what we want to check is following things in the list. The display is set to 1. This is the ID of the Xwayland window on the FreeBSD host. Path is set to include the Resolve bin directory, so we can just type Resolve to open Davinci Resolve. The XDG directories are set up. LD preload is set to load the dummy-uvm.so file. The Nvidia prime render offload is set to 1. Needed otherwise, you'll get a message saying the GPU is full. GLX vendor library name is set to Nvidia. Otherwise, you'll get an error message saying the GPU is full. And the QPA platform is set to XCB. Davinci Resolve uses the Qt framework but doesn't run as a native Wayland application, so we need Qt QPA platform to XCB and not Wayland. So these are the things we need to check: display path, the XDG directories, LD, preload, the Nvidia fixes, and the QPA platform. So come across here to the output of the printenv command and the chroot, and you'll see we've got the path set to op resolve bin. We have our language set here. If we scroll down, we'll see we've got the XDG directories and, importantly, the XDG runtime directory. The LD preload is loading the dummy-uvm.so. We've got the Nvidia fixes down here. Display is set to 1, and Qt QPA platform is set to XCB. PACTL info. Start pulseaudio on the FreeBSD host by running pulseaudio --start --demonize, and then inside the chroot run PACTL info. Then make sure the following options are set. The server string is set to temp pulseaudio.socket. The username is set to the username on the host. The host name is set to the same host name as on the FreeBSD host. And the cookie matches the cookie on the FreeBSD host, remembering that we set that up in a previous step. Okay, let's test the steps setting up Resolve in the script manually. So what we've got here is the Resolve script on FreeBSD, and we'll just check all of these pieces individually to make sure they're working. What we're going to do is just come across, start pulseaudio. Okay, you can see that has now started pulseaudio. The next step is what we're going to do is we are going to run this command here to open an Xwayland window at 1920 by 1080 with an ID of 0. If you're using X11, you can use Xephyr instead, listed below. So what this is going to do is open a display. As you can see here, I'll put that full screen there. And then what we're going to do finally is come down to this section, and we're going to open a new terminal, run the command and switch back to the first display, and Davinci Resolve should open. There we go, there's the splash screen. And there's the project page. And this is so you can test the steps manually, just to see if you're having any issues and at which point the issue is occurring. Switch to the home directory in the chroot if you haven't by running cd. You can list the contents of the home directory in the chroot, and you will see that several directories have been created, including the documents directory. The documents directory is created because we set up the XDG directories in the chroot shell config. So what you will see is cache clip, documents, resolve project, backups, and if you list the contents of the documents directory, you will see is created the Blackmagic design directory as well. So here we are in the chroot, and if we run ls-l, you will see cache clip, documents, several other files that we're using before. But if I list the documents directory, you will see the Blackmagic design directory has been created as well. FreeBSD Resolve script. FreeBSD script to launch Davinci Resolve from a Linuxulator chroot. The window is displayed on FreeBSD using either Xwayland or Xephyr, and the audio is routed over a pulse audio socket from the chroot to the host. This is the path to Resolve in the repository, Davinci Resolve Freebsd, FreeBSD user local bin Resolve. Copy the Resolve script from the repository to the FreeBSD bin directory. So just click that, come across to the terminal, make sure you're just outside of the Git repository, and then run the following command: sudo cp Davinci Resolve FreeBSD, FreeBSD user local bin Resolve, user local bin. Ubuntu. wrapper resolve. After the wrapper resolve script in this repository. Davinci Resolve Freebsd compat Ubuntu user local bin wrapper resolve. Copy the script to the chroot. So click the little button here to copy that to the clipboard. Switch across to your terminal on the FreeBSD host. Check you're outside the repository. And then run the following command. So we're going to run sudo cp Davinci Resolve FreeBSD compat Ubuntu user local bin wrapper resolve, and we're copying it to compat Ubuntu user local bin. Davinci Resolve.desktop. Path to the Davinci Resolve.desktop file in this repository. Path is Davinci Resolve FreeBSD home username.local share applications Davinci Resolve.desktop. On the FreeBSD host, copy the Davinci Resolve.desktop file to local share applications. All we need to do is copy this command and switch across to the terminal. Make sure you're on the FreeBSD host and just outside the repository, and then run the following command to copy the Davinci Resolve.desktop file from the repository into local share applications on the FreeBSD host. And I'll switch across here, and this is the contents of the Davinci Resolve.desktop file, and what you can see here is in the exec line, this points to user local bin wrapper resolve, which is the script we set up earlier, and the icon is set to compat Ubuntu opt resolve graphics Davinci Resolve.png, so that the icon should show up in your desktop launcher. Mount the video directory from the host to the chroot. Allow your user to run the mount command without sudo. You can set this using sysctl. Sudo sysctl vfs.usermount equals 1. Copy that to the clipboard. Make sure you're on the FreeBSD host. And then run sudo sysctl vfs.usermount equals 1. You can also do this by manually editing your sysctl.conf file and setting the following options. So have a look at that file, and you'll see down here vfs.usermount equals 1. Okay, so mount the video directory from the FreeBSD host inside the home directory in the chroot. This allows us to access the video directory on the FreeBSD host from within the chroot with Davinci Resolve. That means we can import and export footage from Davinci Resolve from the video directory on the FreeBSD host, rather than copying the files from the host to the chroot. We're going to create a mount point in the chroot to mount the video directory from the host in the chroot. These commands are run as your regular user and not root. So we're going to copy this first command here, switch across to the clipboard, and we're on the FreeBSD host. So what you do is you run mkdir-p compat Ubuntu home user, and this is going to match the username on the FreeBSD host, and then video. So this is going to create the video directory inside the home directory username in the chroot. And again, because we've matched the user IDs inside the chroot to the FreeBSD host, you don't need sudo. So we create the directory. Next step is to mount the directory from the FreeBSD host to the video directory in the chroot. So copy the command, come across, mount -t nullfs home user video compat Ubuntu home user video. And do you know what it is? On my setup, it's lowercase. Okay, so I'm just going to lowercase those two. If it will let me, there we go. Video. And now if I look inside, first of all, the video directory on the FreeBSD host, you can see here. Now, if I have a look in compat Ubuntu home video, you'll see the same output. So that's how we mount the video directory. and this is how you unmount it. Umount compact Ubuntu home user video, and I'm just going to copy the first part and change that to lowercase. Unmount. Now if I have another look inside that directory, you'll see it's empty, so it's been unmounted. So next step, edit your FS tab on FreeBSD host and set the mount point. So the path to the FS tab is etc FS tab, and this is the FS tab code that we're going to be adding. Home username video compact Ubuntu home username video null FS read write no auto. So what you need to do is change username to your username in both occurrences here and here. We need to use no auto option in the FS tab, otherwise the null FS mount point will be mounted before the ZFS dataset. So you need to manually mount the video directory after you log in by running the following commands and unmounting it. So let's have a look at the FS tab. Yes, etc. FS tab. And as you can see here, mount video from host to chroot. Home username video compact Ubuntu home username video null FS read write no auto. And the no auto is essential, as said, because if you don't have that set up, what will happen is when you try and boot into FreeBSD, you'll get an error and be dropped into single user mode because it can't mount the entry in the FS tab. So that's just something to be aware of. Make sure you have the no auto option set in the FS tab, and then once you've done that, what you'll be able to do is simply, instead of running that full command that we did earlier, you'll just be able to run mount compact, and you can just press tab, and it should automatically tab complete to the entry in the FS tab. So mount that there. Compact Ubuntu home video, it's mounted. Umount compact Ubuntu home video, unmounted. So that's all there is to that step, and that will allow us to access the video directory on the FreeBSD host from within inside the chroot using Davinci Resolve. We'll now take a look at mounting the video directory from the FreeBSD host to the chroot, setting up a project, importing some footage, editing it, and then exporting it. So the first step we're going to do is mount the video directory, and this is something we set up in the previous step in our FS tab. So mount compact Ubuntu home username video. I'm now going to open Davinci Resolve. Here we go, it's loading up. Create a new project. Big buck. Bunny. I'm now going to import some footage. So import media. And as you see, I'm in the video directory here. And this is the video directory on the FreeBSD host. Take the footage, put it in, and what we'll just do is chop the footage up. Just use the blade tool. And one thing I have noticed sometimes seems to be a slight issue with the mouse losing focus, at least for me on my setup. You may have counted this with using virtual machines like VirtualBox. Sometimes you have to release the mouse. What I found is just toggling full screen and back actually fixes the issue, and now I can drag around here. Just thought I'd mention it. So what I'm going to do with the blade tool, just going to come across here, delete that, save it, come across to the render tab, just call it big buck bunny test. And what we're going to do is have a look at the export options. So as you can see from here, you've got the sort of types, the format, but then you have the codec that you can export as. So we've got DNxHD, and uncompressed. So if you have a look at the DNxHD, what you'll notice, you only have certain presets that you can use, like 720 going up to 1080p. Now if you choose the uncompressed option, what you'll notice is the resolution can go up to 3072 by 2048. So if you need a larger resolution than 1920 by 1080, you're going to need to use the uncompressed codec. Now another thing to note is the import and export options. On the FreeBSD, on the Linux version, the free version, you don't have the ability to import H.264 video or AAC audio. With the Studio version, you can import H.264 video, but not AAC audio. You can import ProRes footage into Davinci Resolve, but you can't export ProRes footage in Davinci Resolve 18.6 without a Davinci Resolve dongle, which is obviously paid for. So the workflow is you will need to convert your footage from H.264 into something like ProRes or DNxHD to import it into Davinci Resolve, and then export it probably as DNxHD if you want to go up to 1080p. But if you need a larger size, you're going to have to use uncompressed, and be warned that the file sizes will be very large for uncompressed footage. So what we're going to do is just add this to the render queue, and as you can see, I'm just getting that little issue, so I'm just going to come across here, toggling full screen, and what you'll see is I can select a directory. So what I'm just going to do is, I thought I had this set up. Let me see if, oh yeah, I can toggle it. So I can actually toggle this, and you'll see the video directory here. So I'm just going to click OK, render all. And I'm just doing a very short clip. Okay, so it should be done in a few seconds. And that's going to be saved back into the video directory on the FreeBSD host. So the reason why we set up the video directory on the FreeBSD host to be mounted inside the chroot is that allows us to actually access the footage, so we can import it and export it with Davinci Resolve instead of constantly copying files back into and out of the chroot. So there's the export done. What I'm going to do is actually switch across to another window here, and if I have a look in the video directory, you will see the Big Buck Bunny test.mov file that we just created. So hopefully by now you've got Davinci Resolve installed on FreeBSD, and one final tip is you can click this little icon up here and actually filter the headings. So for example, if you want to search for Nvidia, you can just search for Nvidia and click one of the headings to jump to that section.